All right, just like today in class when we practice this on whiteboards, let's go mark in the picture what we know. So I first want to point out that these are the two parallel lines and the other two are not parallel, not only just based on how they look, but how there's no markings. And so we're told that the measure of angle 3 is 75. So go put that in on the measure of angle 3, 75. And then the measure of angle 13 is 115. So go draw in measure of angle 13 is 115. Okay, so they're asking us about the measure of angle 2, this guy right here. So some people like to just identify the answers they're looking for, and some like to fill in the whole chart, like ready, go, and fill it all in, and then look for their angle after. It's up to you. But what would I use if I have this 75 over here, and I'm trying to go for angle 2? Those are same side interior angles, which are supplementary or equal to 180. So it means I can take the measure of angle 2, my unknown, plus 75, and I know these add up to 180. So I just minus 75 from both sides, and I get that the measure of angle 2 is equal to 105. Can you see that, or is that too small for you? And don't forget the degrees. You got it. Okay, now pause the video and go try measure of angle 5. Okay, measure of angle 5, do you see its relationship to angle 2, which we just found? Measure of angle 5 is vertical angle, and vertical angles are equal. So measure of angle 5 is equal to the measure of angle 2. So measure of angle 5 is equal to 105 degrees from our last example. Done. Angle 7 over here now. Okay, to find measure of angle 7, I've got some info with measure of angle 3. What's the relationship there? You got it, linear pair with angle 3. So I'd say that the measure of angle 7 plus the measure of angle 3, do you see how I'm using a little m for measure of angle? These are linear pairs, so they add up to that. So angle 7 is my unknown. Angle 3 is 75. So I minus 75. So measure of angle 7 is equal to 105. Man, so many 105s, right? Okay, measure of angle 10. You see a relationship there? Measure of angle 10 is equal to the measure of angle 13. Do you remember why? You got it. Vertical angles are equal. And so measure of angle 10 is equal to 115, which was given to us in the problem, degrees. Okay, angle 15 is over here. Angle 15 is corresponding to angle 13. Corresponding angles are equal. So we'd say measure of angle 13 is equal to the measure of angle 15. And so measure, actually I'm going to reverse the way I said that. And so measure of angle 15 is equal to 115 degrees, which was given at the beginning. Angle 16, last but not least, so 15, I now know right here this is 115. So 16 is a linear pair to that. And so do you see how we could say measure of angle 15 plus measure of angle 16 is equal to 180? And we know the measure of angle 15 is 115. And then we're going to just subtract that from 180. And so measure of angle 16 equals, grab your calculator and do this for me real quick. 180 minus 115 is 65 degrees. highlight, and draw this in. Okay, so again, you can fill in the whole picture if you want to, or you can just do the ones that are appropriate. It's up to you. Now we're actually going to be solving some of these. So looking here in 2A, do you see that that's an alternate? Actually, I'm going to make sure to leave lots of space here. Alternate interior angles are equal. So go ahead and set these equals. 6x plus 5 equals 8x minus 11 minus the x's and plus the 11. And so I'm getting that x is equal to 8 degrees. How'd you do? Okay. Next, what's the relationship there? Pause the video, go look at your notes. You got it. Same side interior angles are supplementary. Notice that one looks bigger than the other. 2x plus 6 plus 60, those are going to add up to 180. So 2x plus 66 minus the 66, 2x equals, grab a calculator, do 180 minus 66, and I get 114, divide that by 2, and I'm getting 57 degrees. Highlight. Notice how I'm having to put the reason and the work. The reason and the work. Okay, this one over here can be looked at a couple different ways. 6x minus 12, do you see how that could also be placed here because of vertical angles are equal? And because of that, this is equal to this by corresponding. Well, this is a whole other thing called alternate exterior angles are equal, but it's because of corresponding and verticals. Anyways, they're equal. Let's set them equal. 6x minus 12, 4x plus 28, minus 4x, and then add 12. So 2x equals 40, and so x equals 20. And highlight. 4x plus 28 minus 4x, 2x plus 12. Okay, this next one is corresponding angles are equal again. They're in the same place on the same side of the transversal. Corresponding angles are equal, and that means we're going to set them equal. 6x equals 15x minus 36, minusing 15x from both sides gives us negative 9x equals negative 36. And so x equals 4 degrees. Make sure you're putting those degrees on everything. Those are our units. All right, this is like a two-stepper. First, I'm going to use vertical angles are equal to do the 5x equals 40. Did you see that one? And so this over here, x equals 8 is done. Now I'm going to use this 40 to write a 40 in there because of alternate interior angles. And then I'm going to do linear pair. And so for linear pair, I take 3y minus 1 plus 40 equals 180. That's 3y plus 39. So minus 39 from both sides. I get 3y equals, grab your calculators, 180 minus 39. 141 divided by 3 is 47. So did you see how that one kind of had a trick to it? Where you had to know that that 40 went there? So it's linear pair and alternate interior angles are needed. Okay, this one is also a two-stepper. First, I'm going to do alternate interior angles are equal. And so 7x is equal to 8x minus 10. I'm going to minus 8x from both sides. That gives me negative 1x. By the way, if you get a negative angle measure, something went wrong. It means you did something wrong in the work and you need to go back and check the work. So this one's 10 degrees. And then we're going to go do the other one by your choice. It's up to you. But you could do, so 7 times x, seven times the 10 that we just got means that this angle over here is 70. So we could say 5y plus 20 plus 70 equals 180. Why can we say that? Linear pair. Combine like terms of 90 minus the 90. I get 5y equals 90. Divide by 5. How many times does 5 go into 90? You got it, 18 degrees. What's our reason for that one? That one would be linear pair, because we added those up to 180. So again, remember that we did the reasons and the work. Okay?